Welcome to this lecture on CSS Grid. We looked briefly at CSS layouts in the last lecture, where we learned how CSS Flexbox can be used to define the one-dimensional layout of a single line of HTML elements, automatically wrapping elements onto new lines to fit smaller screens. Here though, we'll take this further and explore how CSS can also be used for two-dimensional grid-based layouts. For this, we'll delve into the world of CSS Grid, an incredibly powerful layout system that revolutionises the way that we create responsive and flexible web designs. We'll go over the CSS Grid concepts and terminology, and then review all of the CSS properties that make up the CSS Grid system. Once you're familiar with the concepts, we'll move on to some code examples where we'll create a simple CSS grid with basic rows and columns. I'll teach you how you can make grid cells span those rows and columns, and even how you can set up named areas within the grid to define exactly how much space cells should take up. We'll then go on to create a simple page layout using CSS Grid. And finally, we'll make that page layout responsive to different size devices by combining media queries with CSS Grid properties. So by the end of this lecture, you'll know all about CSS Grid and will be able to use it confidently in any web page. Okay, so let's get started. The tools used to lay out a web page have varied over the years. To begin with, developers would often use HTML tables to build grid-style layouts to define the different areas of their page. They would then place HTML elements inside of those areas to make up the web page. These layouts may have contained elements such as a header, hero image, feature icons, information cards, and so on, with the layouts around them being defined using the HTML table, TR, and TD tags. This was fine back then as smartphones weren't a thing, so everyone viewed a web page on a desktop or laptop computer, all of which had similar size screens. Tables offered enough flexibility to adapt just enough to different screens in terms of cell sizing, but that was about it. However, when tablets and smartphones arrived, HTML tables were no longer enough. That's when HTML and CSS evolved into other things like floats and absolute positioning. But even with these, it was very hard to create a responsive website that looked good on all devices. Cue CSS Flexbox and CSS Grid, which came along with HTML5 and CSS3. These brought with them a whole host of features that web developers have been crying out for. They were super flexible and totally CSS based, so when combined with the media or container queries, the options for creating layouts were almost endless. Okay, so that's all very well, but what exactly is CSS Grid? Well, CSS Grid is a powerful layout system in CSS3 that allows you to create two-dimensional grid-based layouts for your HTML elements. It provides a comprehensive set of properties and functions to define the structure and positioning of elements within the grid, giving you complete control over your website's layout. Let's just pause there for a second. First of all, don't panic. This is not a whole new language to learn or even a plugin. It's simply part of HTML5 and CSS3. When we talk about CSS Grid, we're simply referring to a set of properties that are supported in CSS3, which we use to style HTML elements such as div tags. That's pretty much it. There really is nothing too complicated going on here. So once you know the CSS Grid related properties, then you'll be good to go. First though, let's quickly go over some terms that you'll need to know because we'll be using these as we progress through the lecture. These are grid container, grid item, grid line, grid cell, grid track, and grid area. Grid container refers to the parent container which contains all of the child grid items, and is the HTML element which has its display property set to grid. Specifying display grid on an element tells the browser that it and any items within it should be treated as CSS Grid elements. It should therefore look for other CSS Grid related properties set against it or its children, and that they should all behave accordingly. In this example, the parent div tag is the grid container. Note that we would typically use a div tag as the grid container. However, because the display property applies to almost all HTML elements, you can use other tags too as a grid container. Grid item refers to the child elements that live directly within a grid container. In this code example, the div tags that reside within the parent grid container are all considered grid items. Note though that this is not because I've given them a class of grid item, nor because they are div elements. I could have named the class anything I like, and they can even be other HTML tag types. They are considered grid items purely because they live directly inside of a grid container. Grid items do support various CSS Grid related properties of their own, such as align self, justify self, grid area, grid row, grid column, and so on, but these are all optional. A grid item doesn't actually need any specific property set against it in order to become a grid item though. That's because the browser already knows that they are grid items because they live inside of a grid container. This means as soon as display grid is given to the container, the items in it will immediately start to behave like grid items. Grid lines are the dividing lines that make up the structure of the grid, and they sit between the cells. They can be horizontal row grid lines or vertical grid column lines, and they live either side of a row or column. Note that the grid lines start from the very edge of the grid. So in this example, column grid line number 3 is highlighted in yellow, 1 being the very left edge of the grid, 2 being the next line to the right of it, and 3 being the one that's highlighted. The grid in this example has 4 column grid lines and 3 row grid lines. Grid cells are the space between grid lines. They are a single unit of the grid, and the example here shows a cell highlighted between row grid lines 1 and 2, and column grid lines 2 and 3. Grid track refers to the space between 2 grid lines, and you can think of these as the columns or rows of the grid. This example shows the grid track between the second and third row grid line. Grid area refers to an amount of space surrounded by 4 grid lines, and can be comprised of any number of grid cells, providing that they are next to one another in a square or rectangular block. This example shows an area mapped out to cover the entire area between column grid lines 1 and 3 and row grid lines 1 and 3. Once an area is defined, a cell can be mapped to it so that it covers a whole area. Assigning a cell to cover an area will push the other cells to the right and down. Okay, so now that you know what CSS Grid is and are familiar with the terminology, let's write some code examples so that you can see things in action. To start with, I'll show you how to create a basic CSS grid. Here I have a familiar blank HTML file. If you wish to code along, you can find a copy of this in your CSS Grid folder within the CSS section of your course downloads. First of all, we need a grid container and some grid items. I'm using div tags here because they're really flexible and work well with CSS Grid. But you can apply CSS Grid properties to other HTML tags too. Here I have a parent grid container, and within that all of my grid items. I've given all of the items a class of grid item, so that we can target them all in just a moment with a single CSS rule. We'll expand on this in a little while when we need to target individual items. But for now we just need to style all of them in one go. With the HTML in place, we can now style the elements and turn them into CSS Grid elements. First though, let's just get some housekeeping out of the way and remove the margin from the body. That way we can get our grid container sitting flush with the edges of the page. With that done, I'm now going to create a CSS rule to target the grid container. That's the div tag with a class of grid container. The most important property here is the display property. In order to turn an element into a CSS grid, you just need to set its display property to grid. That's it. See, I told you CSS Grid wasn't anything too complicated. Now that we've made the container a CSS Grid element, let's just give it a border so that we can see where it sits on the page. Before we add any more CSS Grid related properties, let's run this to see what it looks like. Okay, so far then we've got something that is not even remotely grid-like. But that's okay because we're just getting started. The browser knows the container is a CSS grid, but we've not yet told it how to lay the items out. As a result, it just lists them as individual div elements using the normal HTML document flow. Let's go ahead and style the grid items now so that we can see where they're sitting. To do this, I need another CSS rule to target all elements with a class of grid item. And in here, I'll set the border and background color so that we can see them. I'll give them some padding and I'll center their content both horizontally and vertically using the Flexbox model we covered earlier. Now when we preview it, we can see the individual items still take up a row each, but now they're grey in colour and have a black border around them. Let's add one more property to the CSS Grid container before we start setting the CSS Grid related properties. This will be a padding of 20 pixels, so that the grid items aren't sitting right up against the container. Now we can add in the properties that will turn this into an actual grid. The first one sets up a template which defines the column layout. This property is called Grid Template Columns, and it accepts a space-separated list of measurements. These can be in pixels, percentages, or a new measurement called fractions, or FR for short. Pixels and percentages are fairly self-explanatory as we've used these before, but the FR measurement is new. This simply means a fraction of the available space. So for example, 1FR, 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 1FR would define 4 columns, with each column taking up 25% of the space. 2FR, 1FR, 1FR would create a 50% wide column, followed by 2 25% wide columns, and so on. I'm going to use pixels in this example, but feel free to have a play around with the FR setting yourself. Here though, I'll create 5 columns, and I'll set these to 40 pixels, 80 pixels, auto, 80 pixels, and 40 pixels. The use of auto here means that the middle column won't be a fixed size, but it will shrink or grow to fill up the space as required. If we look at this again in a browser, we can now see a grid layout. That's because we've asked the browser to lay out the items in a 5-column format, and here it's doing exactly that, wrapping cells 6 onwards onto the next line. Now that we've defined the columns and their widths, we can do the same for rows. If we leave it as is, the rows will simply be as large as required by the cell content. However, we do have control over row sizes with the Grid Template Row property. Let's add that now and see what we can do. Just like the column equivalent, this property takes a space-separated list of measurements, each one defining the height of a row. I'm going to use 50 pixels and 200 pixels for this example. Now when we run it, we can see even though our cell content does not require it, the rows in our grid have changed size to match our instruction. The next property that we can use at container level for a basic grid is Grid Gap. This specifies the spacing between the cells, not the cells in the container edge mind. That's already handled by the grid container's padding, just the space between cells. I'm going to set this to 20 pixels, and when we run it now we can see our grid taking shape with cells spaced out a little. There's a 20 pixel padding around all of the cells, and a similar 20 pixel gap now between them. That's great, and our grid is starting to look good. Before we move on to cell spanning though, I'd just like to cover cell justification and alignment, as these next 2 properties give us more control over exactly where the cells appear within their row. The first property is justify content, and in the case of CSS Grid, justification operates at row level, justifying the cells horizontally. If not specified, this property defaults to stretch. So if I just add justify content stretch and run it, nothing changes. However, if I change this to flex start and we look again, we can see all of the cells are bunched up at the start of each row. Note that the first and last 2 columns are still 40 pixels and 80 pixels wide as we instructed, but the middle column which we set to auto is no longer taking up the available space. That's because the cells no longer have to stretch, so the auto column is now only as large as its content requires. Likewise, if we changed it to flex end, it would be like using the right justification in a document. Our cells would all bunch up to the end of the row. As you'd therefore expect, center has them all bunched up in the middle of the row. So while the terminology is slightly different, these are effectively the same as left, right and center justification, which I'm sure you're all fairly familiar with. The extra values on offer that may not be familiar to you are space around, space between, and space evenly. Space around makes sure that the cells are spaced so that there is a consistent gap around each of the cells. One thing to note with this value is the gap between cells won't be the same as the gap between the container edge and the cells. That's because each cell has the same amount of space around it, so the gap between the two adjoining cells will be double that of the gap between the edge cell and the container. That's where space evenly comes in. It's similar to space around, but this time the gap between the container and all of the cells is the same. A subtle difference maybe, but a useful one nonetheless. And finally, we have space between. This value adds as much space between the cells as possible, pushing the cells up against the edges of the container, taking into account any container padding of course. So with all of these justification options at your disposal, you really do have full control over the positioning of the cells. Having just looked at justify content, I'd like to quickly cover align items, which as mentioned earlier is similar to justification, but vertical in orientation instead of horizontal. Again, the default value for this, if not specified, is stretch, which is why our cells are taking up the full height of each row. 50 pixels to the first row and 200 pixels to the second. However, just like justification, the alignment property has similar values of flex start, flex end, center, and so on. And because we have specifically defined the row height, we are then able to choose where the cells appear. For example, setting the align items property to flex start, we'll see all of our cells position themselves at the very top of their row, their height being enough to contain their content. Likewise, flex end will see them positioned at the bottom of their row, and of course center in the middle. If we put this back to the default value of stretch, then we see the cells stretch to take up their entire row height. Okay, I'm going to leave align items like this and put the justify content back to stretch too, because this will lead nicely onto the next part where we'll look at cell spanning. So far then, we have a nice grid where all of the cells line up both horizontally and vertically. However, sometimes we might want a cell to span multiple cell spaces. Take a header for example. This may require a cell to span all 5 columns, so that it is stretched from one side of the grid all the way to the other. Or maybe we want a sidebar which spans multiple rows. In either case, we need to apply some kind of cell spanning, so let's cover that now. Before we do any cell spanning, I'd like to clarify one important thing to avoid any confusion. We are all likely familiar with cell merging in applications like Excel or Word, but cell spanning is a little different. Rather than merging 2 cells together, here I want a specific cell to take up more space, effectively spanning the space that 2 or more cells originally occupied. Spanning the cell spaces like this doesn't merge anything together, but instead pushes the other cells further to the right or down in the grid. We will still have the same number of cells, they'll just be laid out differently to before. Okay, so now that we have that out of the way, let's look at how we go about cell spanning. First of all, we need to tell the browser which items need to span which cells. To do this, we therefore need to be able to identify each grid item individually. At the moment, we can't do this because they all carry the same class. We could give them each a unique ID, or we could add a secondary class to each one. For this example, I'm going to use the latter, and I'll give each grid item a second class of A, B, C, D, and so on. Now, up in the style area, I can start creating CSS rules which target individual grid items. Let's start with grid item A. When we specify cell spanning, we use the grid lines as reference points. For this example, I want this cell to span the first 2 columns. If you remember back to earlier in this lecture, we said that columns, or grid tracks as they're officially known, is the space between grid lines. In order to span 2 grid tracks then, I want grid item A to start at column grid line 1 and fill all of the grid tracks between that and column grid line 3. This effectively spans the 2 columns or grid tracks between those grid lines. The same happens for rows. In this example, I want grid item A to span 3 rows or grid tracks. This means that I need it to span from row grid line 1 to 4. So how do we write this in CSS? Well, to start with, I'll create a CSS rule to target just the grid item with a class of grid item and a class of A. This will apply any CSS properties just to that one grid item. I now have 3 ways that I can specify cell spanning. The first is to use the longhand version and use the grid column start, grid column end, grid row start, and grid row end properties. In these, I can say which grid lines I want the grid item to start from and which they should end on. In our case, as we just discussed, that's column 1 to 3 and rows 1 to 4. If we run this, we can now see that grid item A is taking up the entire left side of the grid. We still have all 10 grid items labelled A to J, but they've rearranged themselves to take into account our cell spanning instruction. Now, let's take grid item number 2, which is labelled with a B. This time though, I want it to span the grid cells that are currently taken up with the items B, C, D, E, F and G. To do this, I'll create another CSS rule to target grid item B, but this time I'll use the shorthand grid column and grid row properties. These will do exactly the same thing as we did before, just in less lines. They accept 2 values each separated by a / character. The first value is the starting grid line, and the second the ending grid line. So here I'll use the settings 3 and 6 for grid column, and 1 and 3 for grid row. Now when we run it, we can see that grid item B spans 3 columns and 2 rows. Okay, so now on to the last method for cell spanning. Here I'm going to get grid item F to span 3 columns and 2 rows. I'll create a new CSS rule and still use the same grid column and grid row properties, but this time rather than using 2 numerical values, I'll tell it which grid line to start on and then how many to span. Here I'm setting the grid column property to start at grid line 1 and span 3. This is the same as giving it 2 values of 1 and 4. Likewise, for the grid row property, I'm using a starting grid line of 4 with a span of 2, which is the same as using 4 and 6 as numerical values. When we run this, we now get grid item F spanning across the grid cells at the bottom. Note that we still have all 10 of the grid items. They've just been reshuffled to make space for the cell spanning. If we look back to the basic grid that we had before, we can see how the elements have shifted to make room. So that pretty much covers cell spanning, at least across specifically numbered grid cells. In this example, I've shown you 3 common ways to achieve it, the longhand method and 2 shorthand alternatives. Now though, we'll take this a little further and look at grid areas. If you remember back to the start of this lecture, I said that this involved us marking out areas of the grid so that grid items could be assigned to them. This is another way to make grid items take up more than just one grid cell, but rather than specifically setting start and end grid lines, we do it with named areas. Let me show you a quick example. Here we have a typical grid which is 4 columns wide by 3 rows high. CSS code to create a grid structure like this may look something like this. Note that in this CSS example, I've asked for each column to be one fraction of the available width, so around 25% of the space taking into account gaps. And we've set all 3 rows to auto so they size themselves accordingly to their content. Let's now recreate this grid using real code. I'll take the code example that we were just working on, and I'll cut it back so that we remove any grid item specific CSS rules. And I'll remove the HTML grid items E through J because we only need 4 grid items for this example. If you want to code along, pause the video and get your code into the same state that I have here on screen. Okay, so let's first run this to see what we have. We don't really see a grid here yet because we only have 4 grid items. And because our grid has 4 columns, they all sit along the top row right now. If we had grid lines though, this is what the grid would actually look like behind the scenes. Let's now set up the grid areas. This won't change the output yet, but it will define which grid cells belong to which area. We do this using the grid template areas property. This property takes a space separated list of strings, each of which takes a space separated list of cell names like this. I like to split the strings into different lines, one for each grid row, but you don't have to. We know from past lectures that the browser will ignore any line breaks in my CSS, so it doesn't cause any issues and it just makes it easier to read. In this code example, I'm giving a label to each grid cell, starting from the top left and working my way right. Labels for all of the grid cells within a row are contained within double quote characters, and then I repeat the process on the next line. I want all 4 cells in row 1 to be the header, the first 3 cells in row 2 to be the main content area, and the 4th cell in row 2 to be a sidebar, and then finally all 4 cells in the last row to be the footer. I have therefore assigned a label of header, main, sidebar or footer to each cell in the grid. Like I said though, this won't actually do anything to the HTML output yet, as we're simply applying the grid area names to the grid cells. If we run it, we still get exactly what we got before. So let's now start telling the browser which cells belong to which areas. We do this by creating a CSS rule for each of the grid items, just like we did before using standard class selectors. Then inside these we use the grid area property to tell the browser which area each grid item should cover. Here I'm saying that grid item A should cover all grid cells which have been given an area name of header. Grid item B should cover all of the grid cells named main, and so on. When we preview this now, we see that our 4 grid items have been repositioned just as we've requested. And our web page now resembles the illustration that we saw to start with. In fact, this is starting to look a lot like a generic web page layout. We have a header bar, main content area, sidebar and a footer. So let's take this a little further then and see if we can use this code to create a full height page layout. As we already have the CSS grid in place and we have our items assigned to the correct areas, all we need to do is make the grid the same height as the page. We've done this before with div tags in past lectures, and because our CSS grid is really just a styled up div tag, we can do exactly the same here. We do this using the height property on the main grid container. And as we've done before, I'll set this to 100 VH. Remember that VH stands for viewport height, and it will make the grid the same height as the browser window in this instance. Now when we run it, we can see that the grid fills the page, plus a bit more, and we actually have a vertical scroll bar. That's because the internal dimensions of the grid itself is the same height as the window, but we also have the padding to take into account. That adds an extra 20 pixels at the top and bottom of the grid. This causes the overall grid to be too large now. Once again though, we've covered this issue in a past lecture where I introduced the box sizing property. If we add this here and set it to border box, it will tell the browser to include any padding and borders when it sizes the element. This time when we look at the page, we can see the ugly scroll bar has gone, and our page is now exactly the same size as the window. Not only that, but if we resize our browser window, the CSS Grid will adjust to maintain its full window size. That's great, and we're now free to place our web page content within the designated grid items. I would suggest using other semantic tags and maybe better class names for our grid items, but you get the idea. Wouldn't it now be great though if we could take this web page layout and make it responsive? You'll see that if we shrink the browser window and make it tall and thin to mimic a mobile phone in portrait view, the grid layout stays the same. It doesn't fall off the edges of the screen, but we've not got much space for our main content or the sidebar. In this scenario, when viewing the page on a device with a tall, thin screen, it would be better to have the grid items stacked one on top of the other. So how do we do this? Well, it's really simple using the tools that we've already covered in past lectures. We just add in a media query to change up the CSS styles a little bit for smaller devices. Let's do this now using the code that we have here already. All I'm going to do here is add the @media section as we've done before, and in there override the layout of our grid. Because the layout is defined purely in CSS, we can change this as we see fit for smaller devices. In my @media line, I'm targeting devices with a screen width smaller than 900 pixels wide. Then inside the media query, I'll create another CSS rule which targets our grid container, and in there I'll override any properties that I need to change for the smaller device. This will be the column layout, row layout, and grid areas. In the new grid template columns property, I'm asking for just one column, rather than the 4 that we had before. This will create a vertical layout where all grid items appear in a single column. In the grid template row property, I am asking the browser to auto set the height from the first 3 rows based on the size of the content, but then set the footer to a fixed 50 pixel height. And finally, I'm defining the areas of our new grid using names. Here, our new grid will have one column with 4 rows, so I'm simply defining the one grid cell in each row as being header, main, sidebar, and footer. Now, when we preview this in a browser, we will see a responsive layout. When in landscape view, which will be the case for most desktop or laptops, we'll see the original layout, with the header running along the top, main and sidebars in the middle, and footer at the bottom. However, when we reduce the width of the browser window, we can see that the layout changes when the browser shrinks to less than 900 pixels wide. When this happens, our grid adopts the new CSS rule that we added with the media query, and the items appear one below the other in a vertical column layout. This is perfect for mobile phones or tablets in portrait view. Okay, so great job. We've just created a really simple responsive web page layout using CSS Grid and media queries. We've also covered basic CSS Grid creation, cell spanning, and grid area declarations. Basically everything you need to know in order to use CSS Grid in any web page. I've created a copy of these example code files and included them in your course downloads. If you didn't code along, please feel free to have a play with these and try out different grid layouts. You'll find a copy in your CSS Grid folder under the CSS section. Next up, we're going to delve into the world of CSS transitions, where we'll explore how we can get an HTML element to transition smoothly from one set of CSS styles to another. So when you're ready, head on over to that lecture and we'll add some life to our web pages.